Let's talk about one of the biggest, most expensive headaches in modern software development, UI testing. We're going to break down the real return on investment when you finally get it right.
So I want to start with just a number, $12,000. Any guesses what that is? A new tool, maybe a fancy server?
Nope, that is the unspoken cost. According to research from NashTech, that's what a small 10-person team can burn through every single quarter, just chasing down unreliable, flaky tests. Think about that. That's money that could be building new features, but instead it's just vanishing into a black hole of wasted time. And if you want to see just how bad it is, look at this. More than half of all the failures in our CI/CD pipelines, the engine that releases our software, aren't even real bugs. They're just flaky tests. This creates so much noise and it completely erodes your team's trust in the whole system, slowing everything down.
So let's really dig into this hidden cost. What are we actually talking about when we say a test is flaky?
Well, the definition is simple, but the reality is just maddening. A flaky test is one that passes, then fails, then passes again, even when absolutely nothing in the code has changed. It is the very definition of unreliable.
So, what's the deal? What's the root cause here? Why are these tests so unpredictable?
Well, it's because traditional end-to-end tests are incredibly brittle. They're tied to a whole bunch of things they have zero control over. Third-party APIs could be slow. You could have network lag. A service could go down. Heck, another test could be messing with a shared database. Any of these things can trigger a failure that has absolutely nothing to do with your code. And that brings us to the solution. If the problem is getting tangled up in all these external systems, well, the solution is pretty clear: isolation. The key concept here is UI isolation. This means we test the user interface all by itself, completely detached from the messy, chaotic world of the full backend stack. We just want to see how the UI behaves in a perfect, predictable world. And how do we do that? Well, with modern tools, it's actually pretty straightforward. We do it by intercepting network requests. A framework like Playwright has this incredibly powerful function called page.route that lets us catch an API call before it even leaves the browser. So here's how it works in practice. It's a super simple three-step dance. 1, your UI tries to request data, just like it normally would. 2, Playwright steps in and intercepts that request. And 3, instead of letting it go out to the real, unpredictable network, it just hands back a perfect, predefined mock response, instantly. The UI gets exactly what it needs, every time, in milliseconds. And that one simple change leads to a massive, totally quantifiable payoff. We're talking speed, cost, and, of course, reliability. I mean, just look at this comparison. It's night and day. Test execution time goes from minutes or even hours down to seconds. Determinism goes from a flaky lottery to absolutely reliable. Your infrastructure costs just plummet because you're not spinning up these complex environments anymore. And maybe most important of all, that feedback loop for developers becomes instant. Okay, I know what you're thinking. This all sounds a little too good to be true. There's got to be a catch, right? What happens if our perfect mock data doesn't match the real API anymore? And that's a great question. That problem has a name. It's called mock drift. It's what happens when your mocks get out of sync with the live API. This is really dangerous because it gives you false confidence. All your UI tests pass, but the app breaks in production because the real data is different. But there's an elegant solution to this. You create a single source of truth, a shared contract. Using a format like an OpenAPI specification, you bind both your backend and your front-end tests to the exact same rules. It becomes programmatically impossible for your mocks to drift away from the real thing. Problem solved. And look, this isn't just some theory. This is the exact playbook being used by some of the biggest, fastest-moving engineering teams on the planet. I mean, just take Netflix. On their tech blog, they introduced a new tool they built called SafeTest. And guess what? It's built on this exact philosophy. It uses Playwright to achieve super reliable testing at a massive scale. And they are not alone. Companies like Stripe and Uber are pouring money into developer productivity and building these kinds of fast, stable CI systems. They get it. This kind of robust, isolated testing isn't just a nice-to-have, it's the engine that powers high-speed development. So let's wrap this up. What's the takeaway? It's really a clear three-step roadmap. First, you isolate your tests with network mocking to make them fast and reliable. Second, you govern those mocks with API contracts so they never drift. And third, you scale this whole approach by baking it into your CI/CD pipeline. That's how you get to truly high-velocity releases. Which leaves us with one last question you have to ask yourself. After seeing all this, the data, the techniques, the validation from the biggest names in tech, is your current testing strategy an asset that's actually accelerating your team, or is it a liability that's quietly slowing you down and costing you thousands?